Hi, I'm Dominic, and this is my problem on gravitation. So my question is, Kyle is standing on the moon, which has a distance of 384,400 kilometers from Earth's surface. So the first question actually doesn't have to, you don't have to use the distance from the Earth's surface, because that just deals with the acceleration due to gravity on the moon. Here's my picture. This is Kyle, first black astronaut on the moon. So the acceleration due to gravity, we can set up F of G equals mass of the moon, so we do little m for mass of the moon, times the mass of Kyle over the radius of the moon squared. So force of gravity, using Newton's second law, we can apply that. Oops. Force equals ma. And that mass will be the mass of Kyle. So we can say sum of the forces equals mk times acceleration. And we'll plug that in for f of g here. So mka equals big M, mass of the planet, mass of the moon, times mass of Kyle over radius of the moon squared. So we can cancel out the mass of the person, which is Kyle, and we get the acceleration due to gravity equals the mass of the moon over the radius of the moon squared. Now we just substitute in the values. So the mass of the moon would be 7.35 times 10 to the 22nd kg. That's the mass of the moon. And then the radius of the moon will be 1.74 times 10 to the 6th meters. And meters is important because you don't want to keep it in kilometers. Most values you'll get in kilometers, but you have to use meters for this problem. So once you plug that in, you'll get the value. Acceleration due to gravity equals 1.67 meters per second squared. This value is 1/6 of the value of gravity, acceleration due to gravity on the planet Earth.
Yep.
So for part B, we got the force of gravity received by Kyle by the planet Earth. Okay, that comes in the picture. And we have the equation set up. So we got F of G, the force of gravity, equals gravitational constant mass of the Earth, which is considered mass 1, times the mass of the person, so we'll say mk because it's Kyle, over the radius of the planet Earth squared. And have the gravitational constant, which we know, G, big G, equals 6.67 times 10 to the minus 11 Newton meter squared over kg squared. And so we'll plug that in there. We'll exclude the units for simplicity. So times the mass of the Earth is equal to 5.97 times 10 to the 24th kilograms. So mass of the Earth times mass of the person, we'll call that 70 kg for Kyle. Might be an overestimate. Over the radius of the Earth, which we were given to be 3.84 times 10 to the 8th meters. So 3.84 meters squared. You have to square that value. So if we solve out for force of gravity, we get 0.19 newtons.